Algebra 1, this is chapter 0.3. We're going to talk about the integers today. And the thing is that these rules apply to not only the integers, they just apply to real numbers. We're going to kind of go back, way back. We're going to go back just to adding and subtracting numbers and then multiplying, dividing. And what some of those rules are. So, I would think by now, all of us should know how to say 2 plus 3. That's what? 5. That's usually not an issue. It's when we start adding positives and negatives together, or two negatives together, things start to get a little wishy-washy, right? So we don't know exactly where we start, where do we go from there. So I suggest, let's try using a number line. And so I got two rules up here. Number one, and I'll clarify after I read them here. It says, make a number line, should be number 1, I guess. But draw an arrow from 0, because we're going to start at 0, and we're going to move the first number. So in our example below, it's -3. So you're going to move to -3 or move -3. Now when I say this, we're moving a distance of 3 in the negative direction. That's where -3 is at, right? It's 3 away from 0, but to the left. So maybe we'll talk about it first. And then step 2 says, draw the next arrow in the positive or negative direction, as many units as the number is, from where you left off, from that first one. So let's actually try this. Number line, nothing fancy, right? I'm going to put 0 in here because it says from 0. Remember, 0 does not always have to be part of your number line. It's there because we're using it. So then, for this particular reason, we want it. If I was just going to graph some points, I wouldn't need it. First number is -3. It means start at 0 and go which direction? Left. 1, 2, 3. There's -3. So if I started here, let me change colors. We'll do orange. So if I started there, right? I would move into this direction here. I'd be here. That's what it means by -3, right? If I had to visualize something, -3 is 3 steps to the left of 0. Step number 2 just says, starting where I left off, add -4, which means move 4 to the left. Because negatives go to the left. So be careful. 1, 2, 3, 4. So starting there, moving to here. Now I stop there. And we just say, what number is associated with there? -7. Count it back, right? So the answer is -3 plus -4 is -7. Now, do you have to use this? No. But for some of us, it's nice to see a progression, a way to show our work, a way to make sure that we're doing things correctly. So, the next technique is adding like terms or like signs and then adding different signs. And I'm going to give you a different way, and that different way is using absolute values or using the fact that signs will change if I combine them in different orders. And so we should probably know what an absolute value is. What is an absolute value? We've seen those before. Yeah.
How much it is away from 0?
Yeah, how much? AKA we've been using the word distance from 0. And it basically makes them what? Distance is always, we talked about this the other day, I think. Positive. You know, roundabout way, basically anytime I take an absolute value, I say it makes it positive. So if I ask you, I'll write an example inside here, absolute value of 3 will equal 3. Absolute value of -8 is 8, right? Because 3 itself is the distance of 3 away from 0, 3 steps away. Negative 8 is also 8 steps away from 0, just to the left, right? That's why we have an absolute value of 8. So, here's some really cool thing. I have this chart that says if you are adding like-signed numbers, 2 positives or 2 negatives, you can say that if they're both positive, that's the first box, the sum of 2 positive numbers will be positive. 2 plus 3, they're both positive, ends in being resulting in a positive. If you add 2 negatives together, it is more negative. It's kind of like people. When you put positive people together, they are more happier. Huh? Put negative people together, the negative Nellies get more negative. Yes? Negative Nellies. I don't know. Where have I heard that from? I don't know what it's from. Not sure. Okay? So, got an example. A, underneath it. I am adding 2 negatives. Again, I skipped over the fact that everybody should know how to add 2 positives. But here we go. I'm going to use this idea of taking the sign away, using absolute values to make this work for me. Negative 11 plus a negative 7. 2 negatives, when added together, will make a what? Oh, that's multiplication. I said added. 2 negatives added together will make a negative. So, watch this. I am going to take the absolute value of each of those, and I will add them together as an absolute value and put a negative up front. Because remember, the absolute values will turn them positive. But when I add positives, I get a positive. My answer needs to be negative. And so, I'll have a negative of, what's the absolute value of negative 11? Plus? And what's 11 plus 7? So it's a negative of 18, which we can say is a negative 18. When you put a negative and another negative together with addition, the number gets smaller, right? More negative. Does everybody see how that worked? I essentially pulled the negative off of each one of them and brought it up front. I did that because that allows me to not have to worry about adding in the negatives. I think it's easier to add positive numbers than it is negative numbers. Now, if I go to them being different signs, and it doesn't matter if it's a positive then a negative or a negative then a positive, if I'm adding them, I will take the absolute values of each of them, again, and subtract the smaller one from the larger one. And then part 2 says it takes the sign of the bigger absolute value, or the one that you're going to put first. So take a look at 5 and negative 8. Which one has the larger absolute value, 5 or negative 8? The negative 8 does, right? So that means I need to take that and make it the absolute value of negative 8. And I'm going to subtract the absolute value of 5, the smaller one from the bigger one, yes? And then I have to put a sign on it. The sign on the one that is going to be the larger one was negative, so the answer overall will be negative. It's almost like if you were having a tug of war, right? And you got 2 people pulling on a rope. One is pulling with a strength of 8, and the other one's pulling on a strength of 5. You know they're in opposite directions because one's pulling in the negative direction, one's pulling in the positive direction. Who's going to win? The one pulling with an 8, right? An 8 is pulling in which direction? To the left or to the negative. So your answer should be negative. It's a negative. What's the absolute value of negative 8? minus? And 8 minus 5?
3.
So it's a negative of 3, or we like to just say negative 3. Opposites, what's it mean to be an opposite of a number? Opposite of 2? Opposite of negative 10. It's 10. So basically, changes the sign. Changes the sign. What do you think the additive inverse then is? Additive means? Inverse means? Opposite, which means? Opposite. Add the opposite sign. So, additive inverse. Add the opposite sign. All subtraction problems can be turned into addition. That's all we're trying to say here. Notice that example 2 says subtract the positive integer. Right now, that's what's happening. It's 18 minus a positive 23, yes? Can't I change that to 18 plus what? A negative 23. And now it looks like the problems we were just doing, yeah? Which means, which one would be the bigger number with an absolute value? The negative 23. And it's negative. So therefore, the negative goes up front. I can take the absolute values of each and subtract them. So it would be the opposite of 23 minus 18. And 23 minus 18 is 5. And so our answer will be negative 5. Now, granted, some of these are fairly straightforward, smaller numbers. They're not always going to stay small. And guess what? They work with decimals. They work with fractions too. So if we can do that here with these nice numbers, later on, you can do it with the not so nice numbers. What's 15 minus 19? Probably don't have to think too much. It's negative 4. But why is that? Because it's 15 plus a negative 19? Or a negative of 19 minus 15. Notice I did there. What did I do? I skipped a step, didn't I? I basically took the absolute values already. And so that's the opposite of 4, which is negative 4. Products and quotients. Funny names for?
Answers to multiplication problems and answers to division problems.
Yes, multiplication and dividing. Now, when you multiply something or divide something with the same signs, positive, positive, or negative, negative, it doesn't matter if you multiply or you divide, the answer will always be positive. If you multiply or divide different signs, positive, negative, negative, positive, the answer will always be negative. So, I think we all know that. A negative times negative is a positive. A negative subtract a negative is always
Negative.
negative. Careful what I said, right? First one, 4 times negative 5. Now, we can use this idea of absolute values, but you got to think. To make it easier, I got a positive times a negative. You know the answer will be?
Negative.
It's going to be negative. So can't I take the negative and just place it up front? And when I do that, all I have to do is worry about the positives or the absolute values. Can you guys tell me 5 times 4? It's 20. And so it's negative of 20 or negative 20. As soon as I say, oh, what's 4 times negative 5? People start to think, oh, I'm not very good at negatives. Don't worry about it. Move it to the front. And then work with nice positive numbers. What about B? Negative 51 divided by negative 3. Right off the bat, you know it's going to be positive. Sometimes we like to do this. Negative, negative makes a positive, so we cancel them. I made those plus signs instead of negative signs. So now all we're worried about is 51 divided by 3. 51 divided by 3, and that is 17. That one might have been a little bit tougher. Negative times a negative. It's a positive, so boom, boom. What's 12 times 14? Answer? 188. Is anybody going to help back that up? 12 times 12 is 144. 144 plus another 24. I don't think it's 188, is it?
160.
Oh, it's only 160. We were close. It's 168. And a negative divided by a positive will make it automatically a negative. And so all I have to worry about is where is 63 divided by 7. Hopefully we all know this one, which would be a negative of 9, which then brings it into being negative 9. Any questions? Homework, page P12, 1 through 23 odds. Yes, that means that all the answers should be in the back of the book. Yes, I want you to check them. Yes, I want you to come with questions if you get them wrong, if you can't figure them out. But no, I do not want you to copy them. I need more than just answers. I want you to show me work. For some of you, that will be a stretch because you guys want to just write the answer. I do not just write answers. You show me work. Have a great day.